Awesome, Stephanie. Thank you so much for that introduction, and just so thrilled to be joining all of you today. As Ellie mentioned in the chat, there are participants from over 29 countries, which is just kind of unbelievable to even fathom. So just really honored to be able to share this space with all of you. Okay, so as you all know, the topic I'm going to be covering today is to answer the question, how do I use AI to fight wildlife crime? Okay, so I'll keep this intro short because I'm sure all of you are very familiar with the poaching crisis. I'm a computer scientist, and when I give this presentation to computer science researchers, I spend a little bit more time talking about this to motivate the problem. But just very briefly, poaching is the illegal hunt or capture of wild animals. Elephants, tigers, and rhinos are some of the most sought after species, and they all happen to also be keystone species in their relative ecosystems. Poaching is a huge problem as it will threaten animal populations, harming biodiversity, harming the local economies there through ecotourism, and also the communities who depend on the land. And it's motivated by the illegal wildlife trade, namely for luxury goods, traditional medicines, and bushmeat. We've been working with a number of parks throughout for our work, but to just make this problem and our efforts a little bit more concrete, I'll focus specifically on some work that we've done with one park in Cambodia called Sripak Wildlife Sanctuary. So this has been in collaboration with the World Wildlife Fund. And Sripak is on the eastern border of Cambodia, adjacent to Vietnam, as seen in green over here. And it's actually one of the largest protected areas in Southeast Asia, with a size of nearly 4,000 square kilometers, which is about 4 times the size of Singapore. And to get a sense of what's at stake, Sripak is home to a population of elephants, deer, and clouded leopard, including banteng, which are these sort of wild cows. And Sripak actually used to be home to a population of tigers, but tigers were unfortunately last seen in Sripak back in 2007 and are now believed to be extinct in all of Cambodia. But fortunately, people have identified Sripak as one of the most suitable sites for tiger reintroduction in Southeast Asia. So there are currently plans and hopes to do so. We believe that Sripak has a capacity to support up to 25 tigers. But of course, in order for tiger reintroduction to be feasible and successful, we need to first make sure that we're able to reduce the amount of poaching there so that tigers aren't immediately poached when they are brought in, and also that they have a sufficient prey population of ungulates to prey on when they are there. Okay, to give a little bit of context on what's being done in Sripak to prevent poaching, and again, probably many of you are familiar with this, but the most prevalent means of poaching prevention is through ranger patrols through this protected area. Here's a picture of some rangers from another park that we worked with in Uganda with the Uganda Wildlife Authority, and they'll conduct patrols throughout the park, noting where they've been with these GPS trackers, as you see in this picture, to note, for example, where they find a snare or an illegal campsite, or perhaps even an animal found captured in a snare. And if it's a live snare, then they'll be able to actually free the animal, but otherwise to try to remove as many snares as possible to prevent them from being able to trap an animal in the future. So then with all the information that they record on these GPS trackers and all the observations they make of poaching activity, all of this information gets uploaded to SMART, the Spatial Monitoring and Reporting Tool, which is a software system that's sort of the de facto, the standard used for conservation management in protected areas. And it's used very widely throughout the world. Probably many of you are SMART users yourself. And SMART, it has been created through a consortium of many different conservation organizations. There are over 9 of them that are all part of this partnership. But SMART enables parks to track all of their information. So for example, here's a picture of all of the different locations that rangers have visited in Sripak over the course of many years. And so just looking at this picture, you can kind of get a sense of like, okay, here's what looks to be a major road because there's just sort of a concentration of points here. And you can maybe even guess where the patrol posts are throughout the park because there are just more patrols centered around those areas, which are would be sort of what we would expect rangers to do, but that means that some of the data that we have is pretty biased because it's much more convenient to go to the roads, it's much more convenient to go to the patrol posts. And as you can see, even though this is many years of data, there are some areas that are in green here that the rangers have never even visited a single time over the course of all of these years. And what's interesting to note, for example, is that some of these areas are actually near the boundary of the park. So even though it's much easier for rangers to conduct patrols from their patrol posts, it's much easier for poachers to come in from the boundary. So you can actually start to see that there might be this disconnect between what the poacher's behavior is and what is the best strategy for them to place snares versus where the rangers are actually patrolling. So what we want to do is try to leverage insights from our historical patrol data and information about where we've seen snares to kind of bridge this disconnect to help rangers identify which areas that they're not going to that might actually be promising areas to where poachers are actively placing snares. Okay, so in order to do so, we've been developing the system called the Protection Assistant for Wildlife Security, or as we affectionately call it, PAWS. And this is an AI system that takes in information about the park and then generates our AI predictions about where poaching risk is highest in this park. So for example, along with all of the patrol observations, for example, what we saw on the last slide, we have all this input information about the geography of the land. And as you might expect, these really dictate how the poachers are going to behave and where they're going to be drawn towards. So if we have information about the roads, rivers, land cover, water holes, animal density, and so on, then hopefully that paints a good picture of sort of, okay, poachers like around this elevation, around this close to a road, with the, high animal density of this species. So those are the kinds of insights that we want to be able to learn from our data, but it just sort of too much data, too many factors for a human to be able to feasibly reason over, which is why a computational method can really help us here, because this enables us to sift through years of historical data, thousands and thousands of patrol points, as well as account for all of these different geographic factors simultaneously in order to make the best insights about more general poaching behavior throughout the park, including in areas where rangers have not spent very much time patrolling. So just as an example on the right here, we show the output of our PAWS predictive system, which are these risk maps of poaching risk in various parts of the park. And we actually break this up into 3 different predictions. So we have our predictions for the overall risks throughout the year, just sort of generally what we think the behavior is going to be. But then we also break it down between dry season and rainy season. And this is critical in a park like Sripak, which is very wet during the rainy season. So some rivers are completely impermeable. You just can't really pass through that. But in the dry season, those dry up and it just becomes very easy to cross. So that really dictates what is accessible to both patrollers and to poachers throughout the park. But it would also be an important factor in helping to determine what the wildlife movement patterns are. And for that reason, we make predictions separately for the dry season and rainy season to account for those changes. And as you can see, there actually is a pretty significant difference in the predictions between the dry season and rainy season. And what's also interesting to note is you can see that many of the more high-risk regions, so the areas that are this darker color of red, are actually near the park boundary. So you can see that there's sort of this high concentration in the rainy season, for example, in the northeast. And as you recall, rangers have not really patrolled that area very often because they just didn't have that much patrol near the boundaries of the park, which are further from the patrol post, for example. But also that this location is near the international boundary with Vietnam, which is along the eastern border. So these are all points to keep in mind. Okay. And then another quick thing I'll mention is that along with being able to make predictions across the different times of the year, we can also make predictions for different types of illegal activity. So here are some results from a park that we worked with in Malaysia called Royal Baloon State Park. And it's a relatively new protected area. They're just sort of ramping up patrols here. So the amount of historical data they have is less. But still, we were able to make some predictions. And hopefully this is useful in guiding their future patrols as they ramp up. But we're able to make predictions here between different types of illegal activity. So rangers will actually note whether the snare that they found is a big trap that's meant to, for example, trap an elephant, or a small wire snare that's meant to trap small game, or a net that is meant to trap songbirds. So here are the predictions that we've generated for each of those different illegal activity categories. And as you can see, the prediction values that we're getting actually differ pretty starkly between all of the different parks, which was certainly of interest to us. And for example, this aligned very closely with what the park managers understood to be the patterns at that time. So for example, songbird poachers are mostly local poachers who are coming in and just walking in. So they would not walk in very far. They would just come in from these just by foot. So going in only a few kilometers into the park and then placing these nets. Whereas oftentimes the big game poachers were coming in internationally from the northern border with Thailand. So it was really validating to see that the predictions that we were getting also matched the intuition that the park managers had from their expertise on the ground about what the conditions are in this park. Okay, so then going back and just putting all of this together, what we have are these patrol observations, and in Sripak we actually have over 40,000 patrol observations that we're able to make predictions on. So, and what we do is we break it up into historical effort. So you can see here the darker blue lines are the places where rangers patrolled a lot, and then the lighter blue is where they spent much less time patrolling. And then we also note where they've actually been able to find illegal activity. And again, you can note here that there's a discrepancy between the areas where they're exerting a lot of effort and the areas where they're finding illegal activity. So they're sort of finding illegal activity throughout the map, but there's, for example, a lot in this south central region of the park, but the historical effort there is relatively less. So again, we're trying to help identify these discrepancies to help the park managers better strategize where to allocate more patrol effort, or for example, to try to answer the question of where should we build a new patrol post, for example. And the illegal activity here, for example, that we're looking at snares, bullet cartridges, signs of humans or humans themselves, campsites, animal carcasses, and so on. So this map shown here is actually the consolidation of all of these different types of illegal activity. So you can notice also that there's sort of like a shortage of positive instances of actual snaring activity. So this is actually another one of the challenges that we had to overcome from a computational and algorithmic level in order to make predictions based on this limited number of examples of snare activity. So that's not something I'll talk about too much in this talk, but we have some computer science papers focused on this, and I can point you to that for anyone out there who's more on the technical side who's interested in learning more. Okay. Yes, again, so based off all of this information, we add the geographic information about the park, and then we're able to make predictions overall. So this is all great. We have predictions. They kind of make sense through this word of mouth discussion with the park rangers who say, okay, this kind of aligns with our intuition about the park. And we've also validated it through computational means, such as looking at the area under the curve and looking at like true positive and true negatives. We looked at the precision and recall, all of these things, and the results that we're getting were pretty good from the standpoint of algorithmic validation. But we also wanted to make sure that these results were not just useful, were not just validated based on these metrics that we're considering, but also that they were actually helpful on the ground. So as a result, we instituted a number of field tests in Sripak, wherein we sent them a predictive, we sent them a map similar to what you see on the left here that identified 15 different regions throughout the park, where 5 of them we had identified as high-risk areas, 5 of them identified as medium-risk areas, and then 5 of them as low-risk areas. But as you can see, they're all grayed out because we didn't want to bias the park managers or the rangers into okay, well, if you predicted this to be low risk, we're not going to spend any effort there anyways. We wanted to make sure that this was a blind experiment from a scientific point, so that we were really confirming the validity of our high, medium, and low risk predictions, as opposed to just biasing them to get the result that we wanted. And what's also important to note is that these regions that we've selected were all areas that were historically of low patrol effort in the past. So this ensured that we were being able to successfully extrapolate our predictions to kind of these important unseen areas, rather than just relying on historical patterns and saying, well, you've always found a snare in this location, so we're just going to send you back there because it makes sense that it's a high-risk area. That would just be that would be kind of too easy. So then this picture on the right is a team of rangers at Sripak with some of their findings from a single patrol. So you can see here that they have all of these just bundles, these rows of wire snares, along with 3 chainsaws that they were able to confiscate from just a single patrol lasting, I think they're 4 days long each. And the most exciting part is when they shared their data back with us. So they sent us a copy of their SMART database, and we extracted out the patrol observations from these month-long field tests and analyzed how many snares did they find in the areas we predicted to be high risk versus how many did they find in the areas we predicted to be medium risk versus the areas we predicted to be low risk. The results that we were getting were extremely validating. They found many more snares in the high-risk areas than in the medium-risk areas, and actually no snares in the low-risk areas, which successfully helped us validate that our PAWS predictive algorithm was able to successfully discriminate between high and low risk areas in the park, which is really useful if we're trying to identify, okay, well, there are all these areas we haven't gone to before, and we only have so many rangers. This is a very limited resource, and the poaching threat is very strong. So which area should we spend time patrolling out of all these numerous unexplored areas? So a system like this will just help them do that filtering to determine, okay, which areas might be a little bit more promising and which areas do we not need to allocate as much time to. And then one other very exciting result here is that in a single month, they were able to find over 1,000 snares, which was extremely exciting considering that in comparison, in a typical month, they would only find about 200 snares. So at least in this case, it was about a 5-fold increase from a monthly average. So luckily, it wasn't just us who was excited about this. Rohit Singh, who leads the Zero Poaching Initiative at WWF, shared in an email, "I am super excited with the results. Let's get this going on other countries too this year," which is just extremely validating to us. And that's what we're doing. So we are expanding PAWS to other countries through integration with SMART. So as I mentioned at the beginning, SMART is this database system that's used for conservation area management. And right now it has the ability to store, to query, to visualize all of your patrol records, but it has no prescriptive component. It has no ability right now to try to say, well, here are locations that might be worthwhile to spend a little bit more time patrolling. So that's where we're coming in to fill this gap and bring PAWS to SMART. So we have a system already implemented, and PAWS is now integrated into this beta version of SMART, where users can just basically hit a button, like choose the options that they want, and then we'll automatically load in very securely, keeping your data private. We'll load in all of your historical patrol data, do this computation to predict which areas might be of high risk, and then output a poaching risk map that looks something like this. So all this work has been done with our team in collaboration with all of the SMART partners. Thank you to many of you who are on here, including James Slade. I saw you posted a message. And also Microsoft AI for Earth initiative, which has helped us with engineering support and also cloud computing resources. So this has really been a partnership through academia, through industry, and also through NGOs and conservation organizations. So it's just been a really wonderful thing to be able to be a part of. So with that note, I really want to emphasize that all of this work has been very collaborative, and we've had a lot of reciprocal dialogue and conversation all throughout. So leading up to these field tests, for example, we were on monthly calls with the team at Sripak, just saying, hey, these are what our predictions are looking like. These are the features that we're using. Is there anything we're missing? And for example, that's when we identified that water holes were really important, because oftentimes poachers will place snares right around water holes, and of course animals need to be close to water as well, and also poachers need to be close to water if they're setting up campsites throughout. So that was one thing that we had previously been missing. It just came about through this repeated dialogue with the conservation experts. But then in 2019, we also had the opportunity to spend a week in Sripak talking with the ranger manager there. So on the left, there's Lee Bora and also Alex Wyatt from WWF Cambodia. And then even had the opportunity to accompany the rangers on a motorbike patrol, which is just really fascinating to learn and witness with the process and just how attuned they are to the wildlife and to the terrain. And at the bottom here is just a representation of all of the 9 conservation NGOs that comprise the SMART partnership. So there have been just wonderful folks that we've had the honor to chat with and work with throughout this whole process. So just thank you to everybody. And to look forward a little bit, and I know that we're about nearing the 30-minute mark. So here are all of the sites where SMART is currently implemented. I think this map is actually missing a few. It hasn't been updated, but there are actually over 1,000 protected areas that are on SMART. And the countries in blue are the ones where there's SMART has been adopted nationally as the thing to use in protected areas. So we're very excited and honored that with this PAWS integration with SMART, we'll be able to be accessible to park managers and conservationists in all of these areas. And then with the last few minutes, I'll talk a little bit just about future-looking work and current projects that we've been working on from more of a computational algorithmic side and how they might be useful in practice. And then some just sort of other ideas that we have looking forward. So when we're looking at SMART and the profile of parks that comprise SMART, that are using SMART, we have some parks that are like Sripak, in which they have a very established team of rangers. They have years and years of historical patrol observations, and pretty comprehensive coverage at the park. So a site like this is really awesome in that they're well resourced, and we have a lot of historical data to leverage with which to make predictions and use in our machine learning algorithms. But that's not the case for many parks. So for example, I mentioned that Roy Balloon was pretty recently established and we're just getting used to the SMART setup. So for example, if they had only started in June and in June of 2018 and we're just doing these initial patrols, this is the coverage that they were able to do in 3 months' time, which is really awesome. But you see that there are many parts of the park that haven't been explored, like nearly the entire northern half of it has just been untouched. So then it's really a question for a park that is just starting out, that might be data scarce. What kind of systems can we use to help them do a better, a more proactive exploration of the park, because a predictive model at this point might not be very reliable since we have such a shortage of data with which to make predictions. So to look at this more broadly, for parks that are data rich, such as this is Queen Elizabeth National Park in Uganda, we can leverage all that historical data to build good predictive models with which we can use to plan patrols. But then for data scarce parks, we want to be able to simultaneously conduct patrols to detect illegal activity and also improve the predictive model. So this is sort of the challenge that we faced, that we were trying to address from a computer science standpoint. And this led us down a path of online learning, which is a subset of machine learning that's trying to proactively figure out, like, okay, which areas should we go exploring, which data will be the most impactful in helping us build up our predictive model more intelligently, while also over time slowly doing more and more what we call exploitation, which is going to the areas that we know to be the most high risk and revisiting those areas. So finding this balance between exploration of unknown areas and exploitation of known hotspots. And this, all of this work has led to publications as well. So these are all published in computer science conferences. So it's really just exciting and inspiring to be able to see that this kind of work that is really focused on real world problems can hopefully also be impactful from a real world setting on the ground in conservation, but also lead to new computational and algorithmic insights by helping us identify problems that are not yet addressed in the current AI literature. Okay, and then just very quickly discussing a subsequent project that we've considered. Here we're thinking about the question of, okay, well, yeah, it's helpful that we're able to make predictions on these sort of general trends, but in reality, we expect that the poachers are actually going to change their behavior, right? So if we patrol an area a lot, you can expect that a savvy poacher will recognize, hey, oh, my snares are being confiscated. Maybe I should stop poaching here and move elsewhere. So we have this hopeful effect of deterrence in which more patrols lead to, in one area, lead to less illegal activity in that same area at a later time. And through analyzing the data from these two parks in Uganda, we were able to identify this deterrence effect. And then we also identified a displacement effect in that more patrols in one area led to decreased illegal activity there, but then increased the illegal activity in neighboring cells. So it's sort of like, okay, one area seems very promising, so poachers will sort of move out of one smaller area and then move into nearby areas, which makes sense. But then now we also want to think about, can we leverage this insight to help us more strategically plan patrols, knowing that there is going to be this deterrence effect. So that's what we focused on in this subsequent paper, where we're thinking about the problem of sequential decision making that's necessary due to deterrence. And then also noting that there's uncertainty in sort of the exact parameters of how much will poachers be deterred, how much will they be displaced, and also like our machine learning predictions of these relative hotspots are imperfect. So there's sort of all of this uncertainty in the environment. So we want to be able to plan patrols that are robust to this uncertainty. And this led us to an entire paper that's using another subset of machine learning called reinforcement learning to develop new techniques that consider this robust planning problem. And then also thinking about the challenge of data scarcity in parks. As we mentioned before, PAWS takes as input all of this geographic information about the land, but that's not available to all parks. Like they may not have a GIS expert. So to help remedy this other form of data scarcity, we have a pipeline in PAWS to automatically get free publicly available remote sensing imagery, which comes from Google Earth Engine, and automatically add that to our PAWS prediction. So if you just give us the boundary information for a park, then we're able to just get all this data automatically. Which we found to be absolutely necessary in some parks, because there was a case in which we were doing some initial field tests of PAWS, and they were running these predictions on Smart, and then one of the park managers came back to us saying, hey, like the predictions I'm getting don't really make sense. They're just looking pretty scrambled. And we went through this whole back-to-back interaction trying to identify like, okay, what's going wrong? And then finally we asked, what are you using to make these predictions? And they responded, oh, just the park boundary. So they were trying to make predictions on nothing other than the park boundary, which, as you can imagine, led to completely nonsensical predictions because we just didn't have any information about the park with which to understand patterns. So just a funny little story. And then this, the results of using this remote sensing data, we wrote up in another paper, if you're interested in checking that out. But overall, there are a number of upcoming challenges that we're considering. For example, this work with exploration and exploitation for data scarce parks is a method we'd really like to test on the ground in some parks. So if you are working with a park that might be interested in something like that, definitely get in touch. We would love to chat about the feasibility of doing this testing. And then we also want to be able to address for things like accounting for real-time changes in patrol plans. So you can expect, or as you know, rangers have to do a lot of adaptation on the ground. If they hear like a chainsaw in the distance or they see a footprint on the ground, of course they're going to go follow that. So trying to think about how we can plan patrols in accordance with that kind of on-the-ground uncertainty. There was a question that I saw in one of the registrations that Ellie shared, asking about marine parks. So certainly that's something we would be excited about expanding to as well. And we also want to think about how we can better adapt to other changes in poacher strategy. So deterrence is one of them, but probably there's other changes to like better accounting for seasonality, trying to address these shifts with like, okay, perhaps the price of ivory goes up, so poacher behavior changes or something like that. So thinking about those other factors. But that's what I have for you all today. Here's my information for how to contact me. I'm happy to be in touch. And yeah, very excited to now move into a discussion. Okay, so let me see how I can end this. Okay.
That was awesome. Thank you so much, Lily. Okay, so we've had a pile of questions come through, so we will make our way through them. But before I get to any of the participant questions, I actually wanted to pull one out from registration, like you've already done. I like that you preempted this. But I wanted to ask a question that Ian Hode actually posed. I think he's here actually, so I'm stealing your thoughts. And he asked, what needs to happen to make this scalable, like across other PAs? I know you've talked a lot about SMART, but what are the next steps? Is it just wider adoption of SMART or Earth Ranger as data aggregators? But what additional data sets need to be collected, and how will these be captured?
Yeah, that's such an important question. And certainly one of the really powerful things about computation is that it is relatively much easier to scale. So for example, if we have all of this work with ranger patrols in one protected area and we want to scale it to another park, we need double of everything. We need double the rangers, we need double the equipment, all of that. So it's just sort of this sort of one-for-one adaptation. But if we have PAWS tested in one park, we've built all this infrastructure to sort of do these predictions automatically. And then if we want to adapt to another park, we don't have to redo all of that. It's already available. So certainly scale is one of the big benefits of computation, and of course something that we want to leverage as much as possible. So that is the primary reason that we've partnered with SMART, because they are just so widely used in all of these parks in 60 plus countries around the world. So being compatible with a database system like SMART will really just, if we make it available to one park, then suddenly everything becomes available to everything else on SMART, which is just this really nice seamless integration. But as I mentioned briefly, certainly it's not the case that what works well in one park works well everywhere else. Which is why we're really trying to go through this period of doing more field tests in a wider variety of parks that have different terrain, different ranger patrol patterns. So perhaps like instead of doing 4-day-long patrols, they only go out like for 1 day. So what changes there? What if in Cambodia they do patrols on motorbike, for example, but what happens if they're doing patrols on boat or on foot or something else? So certainly there's so many different ways that all these patrols happen, and certainly our system is not going to be able to adapt to all of those settings right now, but what we're hoping to do is be able to just scale out slowly and incrementally over time, so that as more things are changing, then we'll be able to try to be flexible to those as much as possible. And then that means the benefits that we've gotten from like more adaptability, then because it's all on SMART, will be available that way as well.
Okay, cool. Okay, Charlotte, do you want to have a go and see if your internet's stable enough, or do you want me to have a crack at yours and Nick's questions?
I'll give it a go.
Ooh, you sound
Can you hear me?
Yeah.
Nice. Yeah, it's just some meetings went very badly earlier today, so I figured best to give a heads up. Yeah, hi. Yeah, thanks for a really interesting talk. My question aligns with a lot of or a few other questions that I saw pop up, but it's basically to do with how you validated, like how successful the model was in predicting where the high, medium, and low risk areas were. Because I was just wondering if, you have this back and forth with the patrol people, and you sort of mentioned that they said, yeah, that makes sense because that is where we would expect there to be more poaching activity. Like, to what extent it might be a self-fulfilling prophecy, as Nick mentioned, where if they're like, this is a high poaching area, so they check it more intensively, so they find more snares, versus a sort of non-biased sweep of the area to really see, okay, without any preconception of where we expect them to be, does this line up with the predictions? Does that make sense?
Yeah, thank you so much for that question, Charlotte. It's so important to be able to do this successful validation. And of course, we're not going to be able to eliminate all of that bias. And I would say actually the biggest bias is not that we shared a predictive map with the ranger manager ahead of time in these initial discussions, but rather that these are experts of the park who have sometimes been doing patrols or been in the terrain for many, many years. So it's certainly the case that, like, okay, if they go to one area, or even if they look in the map and say, okay, even though we've graded out, we don't show that it's high, medium, or low risk, they might already have a guess based on their years of knowledge on the ground of what the predictions are going to be. So that's just something we can't account for at all. But importantly, what we do when we're evaluating like the number of snares in high, medium, or low risk areas is we normalize this to the amount of patrol effort. So we consider, like, okay, how much time are they actually spending there? Because if it's the case that they just spend all of their time in high risk areas and just like 30 minutes in low risk areas, of course they're not going to find snares. So we hope that accounting for patrol effort and normalizing, keeping that consistent throughout will lead to just a slightly more reliable estimates and an evaluation of our high, medium, and low risk predictions. Great question.
Yeah, that makes total sense. Thank you so much.
All right, Dimitri, do you want to jump in?
Sure. I see. Can you hear me?
Yeah.
Yeah, I had two questions. One was because you mentioned about the Malaysia-Thailand cross-border poaching and from Vietnam into Cambodia. I was wondering, kind of a question that leads to sort of a policy. Policy ideas. So, does what you're doing impact sort of policy, like international cross-border cooperation? There's just evidence, or maybe more than that, for them to be able to have to do something.
Yeah, that's a great question, Dimitri, and I would say that is the dream to be able to play any role in sort of influencing policy at all. And I would agree, international cooperation is so essential for this global problem of wildlife conservation and poaching. And certainly, I realized that during the talk, I sort of planted the seed about, like, okay, notice that these predictions are high in this like northeastern region, even though the rangers haven't been patrolling there. And what it turns out is, after our field test, we were suggesting, like, hey, here's like a region in the northeast that ended up being a high risk region, and they went there and they found a ton of elephant traps. And this was an area that they hadn't really been in before, and that was evidence that probably people were coming across the international border to place these elephant traps. And they were asking us again then in subsequent field tests, like, hey, can you send us back to other areas in the sort of northeast region, because it seems very promising. So there are things like that were exciting insights. And another factor in these parks is that oftentimes, even though the protected area goes up to this international boundary, the patrollers aren't able to actually patrol all the way to the boundary, because there's like the border police that's there instead. So there's sort of this like buffer zone that's unavailable, and that was the case both in Sripak in Cambodia and then also Roy Balloom in Cambodia, in which like the region immediately surrounding the boundary weren't accessible to rangers. But as you can imagine, there's probably a lot of poaching activity sort of right at that border, because it's what's more accessible to people crossing the border for poaching. So certainly, I think that more international cooperation is necessary there, but I think that there are many steps before that we would be able to influence policy directly.
Oh, sorry, Dimitri, I did actually mute you if you're talking, because you had quite a bit of feedback, so you'll have to unmute yourself.
Okay, yeah, the other question I had, because it looked like all the sort of poaching that you were describing involves setting traps or that kind of thing. I was wondering how it works with, poachers that are using weapons like guns. And can you use it, because I do bioacoustics, can you do it to sort of determine where the optimal place is to, have sensors, to maybe camera traps or bioacoustic sensors, recording sensors to detect that kind of poaching in more kind of a real-time because I presume you set a trap, you have to go out, they set the trap and go away again, and then come back. But if you're hunting, I guess you just go in, you shoot something, and you take it and go away again, kind of thing. So I was wondering how it works in that kind of scenario.
Yeah, that's another important question. And it's the case that the parks that we've been working with for PAWS have primarily had poachers who have this passive hunting technique in which they're placing snares and then leaving and then coming back a week or two later to see if they've caught anything. But certainly there is this more active hunting with weapons in some areas. And this is not something that we really focus on here because I think there's just, as you mentioned, so much more active monitoring that needs to be done. And oftentimes that would require more resource intensive parks. So there's actually work that one of my lab mates, Elizabeth Bondi, who gave a talk at WILDLABS Tech Tutors during season 2 over the summer. But her work focuses on considering this real-time information in which there are parks in South Africa, for example, that will fly drones because poachers will come in at night to poach. So they have drones that fly around that can like look for heat imagery. So humans will emit heat and so will animals. So the system that she focuses on uses AI to using computer vision specifically that's trying to identify, okay, for this image that's coming in from the drones in real time, can we identify whether or not it is a human in the scene? And if so, then it would trigger an alert and then rangers would be notified.
Great, thank you. Okay, I see a hand up. Is that because you have a question to ask right now, specific to that conversation, or just a general question? Because if you have a general question, do you want to pop your arm down and pop it in the chat, and I'll call on you in a second. Okay, I'm going to go on to Lydia. Do you want to jump in?
Hi. I think my first question was actually pretty much answered at the end of your talk, because I was asking you how you're going to account for the fact that poachers are going to change their behavior with your new ranger patrol strategy. So I think you kind of touched on that. But my second question was just about how you actually account for the biased data source of the ranger patrol data in your models. I was just wondering if you could elaborate on that a bit. Thanks. Also, great talk.
Thank you so much, Lydia. Yeah, those are important questions, and this will delve a little bit more into sort of how can we make predictions with this unreliable information. So one of the primary things that we focus on is the insight that that the more time that rangers spend patrolling in an area, the more likely they are to find illegal activity. So if we have 2 regions, A and B, and rangers patrolled both areas, but they spent 2 hours in region A and only 30 minutes in region B, then if they find a snare in region A and not in region B, then we can't automatically draw the conclusion that, okay, there's more poaching in region A and less in region B, because perhaps there was a snare in the second region, but the rangers just didn't cover that area enough. Perhaps they missed it because it was like down another path that they would have to follow. So we really use ranger effort as a proxy of how reliable the information that we're getting is. So if they found a snare in one area, then we can be very confident in saying that, okay, even if they only spent 30 minutes there, even if they only spent 10 minutes there, we know for certain that there was poaching here because we found a snare. But if they didn't find any types of illegal activity there, then before we just automatically say, okay, there was not poaching there, we first consider the fact of how much time did they spend there. And basically we consider areas where they didn't find snare when they spent relatively more effort there to be more reliable. So if they didn't find snares after 5 hours of effort, then we can be fairly confident that there was not poaching there. But then if they didn't find a snare after an hour, we're not going to be as confident in that. So basically in the machine learning algorithm that we use, we consider this weighting system over the amount of patrol effort, which helps us adjust for that bias in the patrols, because if there's sort of one area that they're only ever passing through, like on their way walking to somewhere else, even though they might visit it on every single patrol, even we can recognize that the patrol effort is very low, so we don't automatically write it off as, oh, there's no poaching here.
Okay, thank you. Yeah, so I should presume then that the areas where they absolutely never went to were just weighted as totally unreliable using that system because there was 0 hours spent there.
Yes, exactly.
Like that. But then how does it work for them when you were testing the model? Obviously you tested it in real life, but before then you were testing it based on your own data set. And then for all of those areas where you would have had predicted snaring or whatever, you wouldn't have had any actual data with which to really know it, validate your model with at that stage. So was that just kind of like, I don't know, a bit of hoping or I don't know.
Yeah, Lydia, that's a really important question. And all of this is sort of like getting at the heart of like computational and statistical evaluation. And what we do there is for all the areas that rangers have not visited at all, we just ignore that. We just say, okay, we're gonna make predictions there, but we're not going to like give ourselves like a yes or a no, like were we right or wrong. We just don't factor that in at all. And then we only evaluate ourselves on how good these predictions were by only focusing on the areas where rangers actually did go. So we say, okay, like let's pretend that we're using data from so let's say we have historical data from 2015 to 2020. So we're going to make predictions from 2015 to 2019 data, and we're trying to predict what the poaching activity is going to be in 2020. And then we look at after we make those predictions, we look at the actual results of, okay, this was what the poacher behavior was in 2020, and then we evaluate for the areas that rangers went to or didn't go to, were we right?
Okay, that makes sense. Thanks.
Okay, John, I'm going to throw to you, but this might not be one Lily can answer. So Lily, if you can't answer this, you can shout and we'll get it answered a different way. So John, do you want to jump in? If John is still here. Okay, I will be John. John's wondering, it's a smart specific question, so I'm not sure how, but you may be able to answer it. So he asked, how do you protect smart from poacher hacking access? So it's a data security question. Do you have any insights on that?
I'm sure there's so much that's being sort of done under the hood that I'm not aware of, but I do know that like all smart databases are password protected, and they live on like a local computer. So none of this information is on the cloud. It's not like a poacher can just sort of hack like, okay, I'm going to like log into like the smart website and then try all these usernames and then get in. They would actually have to physically be looking at the computer that the rangers are using, that the park manager is using, in like whatever their headquarters is, or their main patrol post, or even a headquarters in like a further city or something like that. They would have to physically be at that computer in order to try to log in and then access the data. So that's certainly like one level of protection that they have in place, and there might be others as well that and if somebody here knows more about smart and that data protection, please chime in.
So Ian's just made a comment that I was going to make. I'm fairly sure Smart Connect is on the cloud, so I'm actually not going to get you to answer that question. What we're going to do is, oh, James, are you here? Can you answer it? Is that why your hand's up?
Hi there. Yeah, can you hear me okay?
Yeah, we can.
Yeah, great. So hi everyone. I'm James Slade from Rewild and the Smart Partnership and the current capacity council chair for Smart. Yeah, so there are manuals available for the best security practices for data security for Smart, which you can find online. If anybody does have any issues finding those, please just reach out to the Smart community or to myself and we can get those for you. But exactly as Lily said, Smart is predominantly a desktop-based system, so you would need access through the passwords and through the to actually have access to that specific smart database in order to get data from that. Whereas on Smart Connect, it is a cloud-based system, so you're basically, your security is as good as the system that you're using. This is one of the reasons why we are hesitant to recommend that people use local servers, because of the security implications of that. You do need to write your own security certificates, etc., which can leave you open and vulnerable. But if you're using a system like Amazon Web Services or Azure, which we recommend, then you've got as the security which is as good as those systems provide. So always recommend go with a well-known provider to use your Smart Connect with. Hope that helps.
It does. James, while I have you, Lily, forgive for a second. I'm actually just going to see if you can take on Jeremy's question as well. Jeremy, do you want to jump in?
Certainly.
Can you hear me?
Yeah, we can.
Okay, great. I was just curious as to what kind of the biggest obstacles or limiting factors to get parks to uptake on this SMART program.
Sure, yeah. I mean, in my experience, having implemented SMART in, I don't even know how many countries around the world now, the biggest issue that we find with SMART or Earth Ranger or any other platform is mainly that institutional will. SMART and Earth Ranger are extremely customizable programs. They're designed to be site specific. So it's not an out-of-the-box tool that you should expect to just implant in a site and start running with. You design it for that specific area. You customize it for that protected area or conserved area's needs. And so the willingness to invest in that can often be one of the main limiting factors, as well as people not willing to invest the time into making sure that all of the components of what you're doing with your protected area, such as your management plans, your operational goals and targets and everything are clearly reflected in SMART. And so people can become frustrated expecting that it's not turning around the results that they need, but it's basically down to the infrastructure that you have, the institutional willingness to implement something like that is so customizable, and then your resources available on the ground. So if you don't have the resources to conduct patrols and to do field activities, well, then you're going to struggle to use something like SMART. So that's, in my experience, the biggest challenges beyond even having people in the field that can be taught or are able to pick up a system like SMART or Earth Ranger. Hope that helps.
Awesome. We have one. So sorry. Okay, everyone, I realize we're on the hour. Ellie says that you're okay to stay a little longer. Is that true? Okay, awesome. Right. One last SMART question. Bubby Valiap, I don't know who you are. Can you tell us what your name is? And do you want to join in the conversation? And James might be kind enough to take this as well.
Hello.
There we are. Hi.
Hi, everyone. Am I coming out clear? My first question was, is it feasible to set up a local server? I think it's already answered to set up a Smart Connect on a local server. But now I would want to know the resources that are needed to set up our Smart on a more protected server like Amazon, the one that you recently mentioned. Is it costly? And what other resources are needed for us to set up that Smart Connect server? Because we already have got Smart on our desktops in Earth Ranger running, but we are expecting to start implementing Smart project in some maybe 3 months to come. But now the clarity in terms of the budget that we need to run up in terms of the server setting, it's not clear on our part. Can you please clarify on that one?
Certainly. Sorry.
You asked my name. I'm Lloyd.
Great. Hi, Lloyd from the Bubé Valley Conservancy. I know the area well. Zim was my previous home before moving back to Canada, so great to see you on here. It's a little bit of a lengthy question to answer on this call. I'll tell you what, we are working with the Zimbabwean government as a part of the national rollout for SMART there. We are looking at a national server network for Smart Connect. However, if you are looking for a local setup for Bubé Valley specifically, I can certainly assist. We've just refined some materials on setting up local servers. We're testing a new beta setup, which is more of a package that you can download that will help to get your setup for Smart Connect without having to go through the whole Tomcat setup and everything specifically. So I'll pop my email here in the chat, and anybody that is looking at setting up Smart Connect or would like any further information on Smart, I'd be happy to point you in the right direction. Another option is to join the Smart Community Forum in which we can field any Smart specific questions that you might have, because I don't want to take up too much of Lily's time. Thanks, everyone.
We have managed to turn this into a smart discussion, but thank you, James, for taking on some questions, and thank you, Lily, for being so patient. But James, we might actually have a chat to you offline about running a smart session. So either as tech tutors or some other stuff. So there seems to be a lot of questions from this community and others. So we'll sort that out later. Lily, right, back to you. Our focus. Who is Rob? Would you like to take the floor? And you get one question. That's all.
What? One? All right. Lily, great talk. Really, really interesting. My question is, in that graph where you said that you found about 1,000 snares during that one kind of survey that was done, is there any idea how many people might be involved in putting out 1,000 snares? Like, just to sort of get a picture in my head of how many people are involved in this sort of stuff.
That's such a great question, and I wish I knew. I'm sure the rangers in Cambodia wish they knew, and just really, there's no way to know. But what I've heard from the folks in Cambodia is each snare costs about 25 cents to make, because it's just a wire snare, and you can just oftentimes they'll get it from like the wiring that people use for like their motorcycle brakes, I think. So like you'll go to like a bike repair shop and then buy all these like wires and then just cut it up and fashion them into snares. And what I've also heard is that sometimes people take tires, like car tires that have been abandoned on the road, and strip out the wiring inside of that tire, and then it's just a free wire that they can make into a snare. So they're extremely cheap to make. They're very lightweight and easy to carry. So poachers can easily blink at the ground with snares. And the estimate that they have in Cambodia and Sripak from ecological surveys is that for every one deer in the park, there are 4 snares, which is a shocking number, and just very really shows us that if we don't take proactive action, then the wildlife can easily be wiped out.
Wow, that is awful to hear. Okay, well, thank you. That gives me some perspective. Thanks, Lily.
Hey, Harold, you also had a snares question. Do you want to jump in?
Hey, it's a really great talk, Lily. Thank you very much. I was also curious about the snares. Like Rob, it was more about maybe you can answer this in greater detail. Can you estimate how many snares you did not find based on the number of snares that you did find? And then also, do you have any idea if these poachers who are using snares, if they are poaching to sell bushmeat, or is it for subsistence? And the final question, which I'll just sneak in, is I'm interested in dynamite fishing, and you mentioned you're going to look into modifying PAWS for MPAs. I'm wondering how you would go about what kind of work would be involved in performing this modification. Thank you.
Very interesting questions all throughout. And so just to go in order, Harold, your first question of how many snares do we not find? No idea. Because I've seen some studies, and one of the questions in the chat was somebody had asked about if it's possible to sort of disable a snare so that it's not going to harm animals, and then set up like a camera trap or something like that to see if anything, if poachers come by or if animals come by or anything like that. And there have been some like scientific studies that people have done that's actually placing imitation snares on the ground, and they'll have rangers conduct their patrols and then estimate how many of those like imitation snares they find, which gives us a sense of, okay, are rangers finding like 10% of snares, 50% of snares, or what? I don't remember the exact number, but I think the number was close to 10% of snares are actually found by rangers, which is unfortunately very, very small. And because of that, they estimate that the most impactful, along with physically removing snares, one of the most important impacts of ranger patrols is deterrence in deterring poachers from coming back into the park. And then your question about marine protected areas. So it's not very straightforward exactly how to adapt PAWS to MPAs, but this is certainly a point of interest to us, and also offers probably some really interesting computational questions as well, because this is kind of an unknown, because with MPAs we just don't have as much information, you know. So with protected areas, we have rivers, we have roads, we have villages, we have land cover, we have elevation, and we just don't have any of that with marine areas. So we have maybe some information about, okay, what is the sea level looking like? How far is it from the closest coastline and stuff? But otherwise, it's just sort of like a dearth of features. And then also, of course, you have the challenge that like marine animals move a lot more freely through a marine area, and as do poachers. So like poachers, or like their boats, they're illegal fishers, their boats can move a lot more freely through these areas. So certainly those are hard questions, and that all of those factors make some of the aspects that make PAWS work completely useless. So there is not a very straightforward adaptation, but that those challenges are sort of why we're excited about it, and why we're really interesting to explore that more.
Thank you.
Awesome. Okay, Ritwi, do you want to go next? If you're still here. Okay, I'll ask this question. This is the second last question, Lily, just to give you a heads up. Okay, what kind of model performance led to real life good performance in your experience? What should we aim for roughly? What to aim for roughly?
So that seems to be more of like a computational question. So the answer, if you're familiar with this terminology, is we think really good performance would be about 0.8 AUC, area under the curve, and like satisfactory performance would be about 0.7. So for those who aren't familiar with this, basically AUC is a metric of how many like positive instances do we get right, and how many negative instances do we get right. So it's like for the areas where we predicted there was illegal activity, how many of them were we actually able to identify? And the areas that we predicted there was not illegal activity, how many of those were we successfully able to identify? So then an AUC of 1 is perfect. That means we got everything right. AUC of 0 is we guessed everything completely wrong. And then an AUC of 0.5 is just as good as randomly guessing. So it's like, okay, we would do like a 50-50 coin toss, basically. So 0.8 is fairly good. In some other settings computationally, we would expect something like in the 0.9 or 0.95, but just with the poaching domain, there's so much just randomness associated with all of this. And the poacher behavior changes a lot from month to month and stuff like that. So we can't expect to get anything too high, but if we get something above 0.7, we're pretty happy.
Did that answer your question? You can just type in the chat. It sounded like it was along the right lines. Okay, I'll swing back around. Okay, final question is from Stephen, who asked, protected area management simulation. Oh, wait, first he said, fantastic talk. So got to get that in there. And what he asked was protected area management simulation and modeling, question mark. Considering the vast amount of feature variability between protected areas that you mentioned, what are your thoughts or observations around the efficacy? Did I say that right? Efficacy? Yes, of protected area management, simulation, and modeling. For example, iteratively training predictive models on synthetic smart data sets of simulated protected areas that might include and allow for different models of transportation, frequency interactions between simulated and synthetic rangers or poachers. Would it be easier to read that question? Or did
I think I have a sense of what Stephen asked. So certainly, the ideal scenario that we can do is we just take information about 10 or more protected areas, and then we train some universal model and say, okay, this is how we think poacher behavior is going to be universally across the globe. But we can't do that because protected areas are so different, because the animals in each park are so different, because the poacher population there is so different, like what they're able to sell, for example, on like the local or international legal market. It just varies so much. And of course, ranger capacity is different from park to park. So there's just too much variability between parks to be able to learn some sort of universal model. But that doesn't mean that all of this is impossible. So if we are looking at, for example, one park, and then let's say that we expand that park to a local region, or we like build a new protected area adjacent to it or a little bit away, provided that enough of the information is the behavior we would expect is the same, if like the animal populations are like somewhat consistent and stuff like that, then we could feasibly train based on the data that we have in this established protected area, and then extrapolate that to get some early predictions for the other local protected area. But of course, there are limitations, and we would really want to make sure that these things are very similar. So, for example, the two parks that we worked with in Uganda, Murchison Falls and Queen Elizabeth National Park, even though they're both in the same country and like relatively close apart, relatively close together, one of them, I forget which, is like a big savanna, like big grasslands and stuff like that, and the other has a lot more elevation. So it's just not feasible to extrapolate between these two parks. And like one of them has giraffes and the other doesn't have giraffes. So there's just, even with two parks that are relatively close in the same country, it doesn't make a lot of sense to transfer these kinds of predictions. And if we had something like a simulated model, like what you're saying, that might help if we were able to really have a good understanding of that. But that would the tricky thing there is, if we were able to build a good simulator, then we would already know what the poacher behavior is, because in order to build an accurate simulator, you need to say, okay, how are we simulating this? And then you have this, then there would be no point anyways.
And one final question for me, just to wrap up, and just to say thank you so much. This has been just wonderful. One of the people asked as they were registering, Parami, she asked, how do you stay hopeful when you work in wildlife crime? What makes you hopeful?
Yeah, I had seen that question from the registration forms that Ellie sent, and I loved it. So great question, Jeremy. And I think that it's certainly discouraging. And then every time I look more into this, I see all those stats of like, okay, the elephant population is 4% of what it used to be 100 years ago or something like that. It's just really discouraging. But I think that gives me optimism, because that means just like the problem is so much more urgent now and important. And it seems like more and more people are paying attention, you know? So for example, with climate, which I think a lot of people see as a bit closer to home because it's really going to impact them, like what we have in the United States right now with all these wildfires on the West Coast and floods on the East Coast. Then people are recognizing, okay, this hits close to home, and people are paying more attention to environmental issues and being mindful of their own actions, and sort of thinking about how we can use policy to help enact change. So I think that people are caring more and more. But then also, every time I come to a forum like this with just an amazing set of conservation folks, I just get there's so much creativity and expertise and passion among all of you, and that was really exciting. And one thing that made me so bummed is I was supposed to attend the ICCB for conservation biology conference in Rwanda in December, and then they announced that it was going to be virtual. So unfortunately, don't get to chat with any of you who might be there in person, but there's still these venues like WILDLABS Tech Tutors, where you can at least gather in these digital spaces.
I think it's holding it together and pulling us through, right? Until we can see each other. I'm just going to stop spotlighting Dimitri. Right. I think that's 20 minutes past the hour. I feel like you've done above and beyond your duty here. Thank you so much for joining us and bringing such enthusiasm to this talk. And yeah, I've wanted to have PAWS. I wanted to learn more about PAWS for a really long time. So it's been an utter delight to listen to you today and hear what you've been working on. So thank you so much. And everyone, we'll see you next week for a talk with Alistair Davies, who's jumping in. We had a speaker have to pull out. Alistair's jumping in, and he's going to talk about using how do I use satellite IoT, Internet of Things tech to track wildlife and monitor remote equipment. So it should be a really fun, interesting talk, especially if you're interested in satellite tech and IoT. He'll give us a really good run through about how we can apply that to conservation effectively and what you should be aware of. So join us next week. But everyone, please say thanks to Lily, and we'll see you all next week. Thanks.
Thank you so much, Stephanie, Ellie, and the whole WILDLABS team, and all of you for just such phenomenal engagement. I hope to see you all